Okay, up next is Aave. So Hadrien's going to give us. There he is. Hadrien, you ready for our introduction to for developers to Aave? You're on mute. Go ahead and unmute yourself.
Hey, yeah, just having a quick issue with the screen sharing, it seems. So hope to be here really quickly.
No problem at all. Take your time. This is where I do a little dance, or I like.
Yes, please do something like that.
I'll just remind everybody about poker tonight. Go to the CryptoVoxels metaverse. Check out the art auctions. Support the community. Support the art community. This is really important stuff. I mean, we're doing a giant experiment here and creating ETHDenver virtually. But so far, I mean, as much as I would love to be in front of everybody, which is priority and preference, like the ability to like connect with people the way that we've done this has really been pretty cool. We were on Minecraft last night chatting with people. We were doing all sorts of interesting things in just different components of the gamer jibe space. We had a couple icebreakers yesterday. We actually watched teams form. So it's been a good time so far. I'm enjoying myself. John is a poker hacker, grabbed me for 2 ETH. Yeah, probably did. Yeah, you don't want to probably come play against me tonight. Yeah, don't come. You'll lose. I'm going to win.
Just hey guys, can you hear me all right?
Are you ready now?
Yep.
Okay, all right, good? Take it away.
Let's go. So hi, I'm from Aave. I'll try to give an overview for devs of the protocol itself and give you a good idea of what's possible with the protocol. So Aave, really quickly, it's a liquidity protocol. You have people or entities that can deposit assets into the protocol and they earn interest on it. And you have on the other side people that can borrow these assets. For that, they need to have collaterals deposited also. And yeah, that's the core value of Aave. So as of today, we have more than $5 billion worth of assets inside the protocol. We are pumped about this, but this is only the beginning. And so here are the main features. You can deposit, that gives you access to interest. You can borrow, and with this, increase some of your position, or you can do whatever you want with this. And we have introduced new capabilities in the credit delegation. And we have flash loans V2 that are really interesting, and our governance that we think is one of the best out there that we upgraded really lately. So in V2, what's new? It's the possibility to make batch flash loans. So you can flash loans on several assets at the same time. You can interact with the protocol itself while doing a flash loan. That was not possible in V1. The debt are tokenized. So when you borrow an asset, you have a tokenized debt. We have the credited delegation. We'll talk about that. The governance V2 again, that has many delegation capabilities and that separate the voting and the proposition powers. We have made some efficiency, better efficiency in the gas usage. We have access to wrap ether inside the protocol, and we have the permit of EIP 2612 that allows for single approval and transfer. So now the first thing, the most simple, it's the earn. You let basically people borrow your money and you earn interest on it. And we tokenize this asset. So in the form of a token. So let's say you deposit DAI, you get a DAI. And one a DAI is always equals to and redeemable to one DAI, but your amount of a DAI will always accrue thanks to interest. So as soon as you deposit DAI, you get a DAI, and this amount is increasing. So now for devs, it's pretty simple. I won't spend too much time on this. But here we are going to deposit some DAI. So here it's the address. You want to deposit 100 of DAI. And so first you need to approve the lending pool of Aave. First, just I'm going to give you an idea, but we have documentations that we try to keep updated, and that should give more information. I give you a mental idea of everything that's possible. So we approve the DAI, and then we can deposit DAI. Here you can see that there is a on behalf of. So here we are depositing for ourselves, but it's possible to deposit DAI and that somebody else gets the A DAI. So here we deposit some DAI. Now the amount of A DAI that we have is always increasing. Every second it's increasing due to interest. And when you want, you can withdraw them. So here it's how we do it. It's just calling the lending pool. It's our core contract in V2. And you withdraw the asset you want. Here it's DAI. And so you get, here we chosen the maximum, the UINT -1, that is the max of UINT. And that means that you're going to withdraw everything. So all your DAI plus interest. So on the other side, you can borrow. So basically, you need money, you can borrow, but you need to have deposited before. Like, actually, with credit delegation, it's a bit different. But let's say that sometimes you can borrow, sometimes you cannot. If you have collateral, you can borrow a certain amount, and if somebody has delegated credit to you, you can also borrow without collateral. But we'll get to that later. So basically, before we deposited DAI, so we have A DAI, and against this we can borrow tokens. So let's say that you have deposited Ether, you get A Ether, and you can borrow DAI to do whatever you want, to farm, to do something. So yeah, so let's see how it goes. Here we're gonna borrow some DAI. So here we can choose actually between so we'll have to pay interest on this loan. So we can choose the interest rate mode that is or stable or variable. And so here that's what we do. We are borrowing DAI with a stable debt mode. That means that we know in advance what the interest rate APY will be. And so that's it. Here we borrow a set on behalf of ourselves, here, message.sender. So that means that we need to have collaterals before. We need to have a ETH or something else to be able to borrow DAI. So here we borrow DAI. We'll get to that later, but if somebody has delegated credit to you, given you access to his collateral, their collateral, you can borrow on behalf of them. So at any time you can swap between the stable debt model or the variable debt. So stable interest rate or variable interest rate. Just know that when you move from variable debt, variable interest rate to stable one, you'll have the latest stable rate. So that means that sometimes you don't want to do that because maybe you secured a good stable rate before and you don't want to update it, just for you to know. So now you borrowed, and so now you can repay. You can repay with the interest. So here you need to approve again so here we're gonna repay the DAI debt that we just contracted. We're gonna approve the lending pool for DAI, and again we're gonna repay on behalf of ourselves. And this will you repay the debt. And so let's say that you had deposited Ether before, now you can withdraw your Ether. So now credit delegation, this is really interesting. This is what we've been developing for V2. Basically you have collateral, you want other to borrow against this, you can do that. You can delegate credit to someone else. So that's it. You give your credit line to somebody else. I think it's really interesting, and there's so much potential to develop around that. You could create smart contract on top of this to create your own loan mechanism, or even off-chain contracts. So let's say you can borrow 100 DAI. You give this borrowing capability to someone else, and in the real life or off-chain or in any protocol, you create another contract with this person. And what's great is that for the person you delegated your credit for, he's contracting under collateralized loan. So that's really interesting. So here how it happens. So here we fetch. I think that this is not the real function. It's more get rid of data or something. But you fetch the stable debt token and the variable debt token of a certain asset. Let's say here it's DAI. So here you fetch the address of stable debt of DAI and variable debt of DAI. And what you will do is that you will here on the two last lines, you approve a borrower to increase your debt, your stable debt or variable debt of DAI. So let's say that I deposited some Ether and I didn't use my credit line. I will say to someone else, hey, now you can borrow DAI against my collaterals. So that's what happens here. And so now the borrower, he has now my credit line. He can now borrow from me. He can borrow DAI from my collaterals. And what he will have to do is that he will do as we done before. He will call the lending pool and the borrow function. And this time he will say on behalf of me. And that way he's borrowing DAI, but it's myself that get a debt. And so that's why we need another contract somewhere else. He wants to, and if he doesn't, it's going to be up to me to repay the debt, because this debt of DAI that he contracted is linked to my accounts. Again, I delegated credit to someone else. He can also, let's say that he borrowed from me some DAI, using my collateral some DAI. He can then repay my debt. And by doing this here, it's because he's repaying and on behalf of myself. So that's how you can think that you can also create smart contracts on top of this. And there are so many interesting things that you can do. I love the ideas around delegated credits together, let's say a community. Each member delegated credits to a pool, and from this pool we will do some loans to support our community. I think that's really interesting, and we've already seen great projects having fun with this. Now, flash loans. This is also a capability that was well known this summer, especially. It allows you to borrow from our pool of assets and an unlimited amounts, and you will pay a low interest rate on this. The condition is that in the same transaction you will have to pay back the amount you borrowed. And actually, so it's really interesting if you want to do arbitrage, or if you want to swap collaterals between Maker and Aave, or if you want to do some kind of migrations. And in V2, what we introduced is the ability to not actually repay. So you borrow an amount in a transaction, and you can repay it in the same transaction, or at the end it will settle as a debt if you have enough collateral, of course. But we'll see that a bit more. So flash loan, really simply, how it works is that you have here on top of the purple line, you have someone that wants to call a flash loan. So he calls the Aave protocol. Again, it's the same contract, the lending pool, and you call the function flash loan, and you say, I want you to get DAIs, and then you do whatever you want with DAI. The only condition is that at the end you give back the DAI to the protocol. And actually, it's V2, it's the protocol itself that will get them from you. Anyway, so what you could do is that, for instance, you can swap the collaterals in a maker vault. So you can flash loan some DAI, repay some debts, then get back the collaterals, and swap these collaterals for another asset and put them in another maker vault, and then borrow again DAI, and that's it, repay the flash loans. So it's really nice to do usually migrations when you have some collaterals and debt. That's really interesting. You can do also, of course, arbitrage. Let's say that you've seen an opportunity to protocols that are creating the same kind of assets, but where the price differs. You can borrow DAI to make arbitrage between these two platforms. And in V2, you can flash borrow several assets at the same time. And yeah, I think that's really interesting. So here, effectively how it works. Here we're gonna create a contract that will do two things. First, here we call the flash loan function from the protocol, asking for here two assets. So here asset 1, asset 2. Just 2 seconds. I'm not sure if. Yeah, that's good. Sorry. Yeah. So this is your contract, and you want to flash borrow two assets, and so you're gonna call the lending pool of Aave, and you're gonna call the function flash loan. And here, this contract will also so the flash loan, how it works really is that you ask the protocol of Aave protocol, hey, please give me some assets, and what the protocol will do is that it will give you the assets, and it will call a callback function, and we will see it here. It's the execute operation. So here, when you call the flash loan function, the receiver address should be a contract that implements this function, the execute operation, because this is the function that the protocol will call. So here we say that we want to get these two assets, and we want to get them back in receiver address. In that case, the receiver is the contract itself, because this contract, as you see, has two functions. The first one to call the flash loan, and it has also implemented the execute operation function from that will be called by the protocol once you call the flash loan function. So just a difference between V1 and V2. In V1, you had to, at the end of the transaction, you have to repay what you borrowed. You had to repay what you borrowed, and in that case, it's the protocol that will pull your assets at the end. So here, you need in this function to approve the lending pool of your assets. Okay, because yeah, again, it's the pool that will pull your assets at the end. Just a quick note, as I said before, here you have the modes. So for the asset 1 and asset 2, you can set different modes. And if you said that the mode you are using for this asset is 0, that means that you need to repay the assets at the end of the transaction. Like if you borrowed 800 DAI, you need to pay back within the same transaction 800 DAI plus interest. If you choose the mode number 1, at the end, and of course it will the transaction will revert if you didn't pay back the 800 DAI in the case of mode 0. In the case of mode 1, if you didn't repay the borrowed amount, it will create a stable debt for you. And that means that, of course, you need to have enough collateral. But if you have enough collateral, it will create a stable debt. So you can make a flash loan and not repay everything. And that's really interesting against if you want to do some margin position or stuff like that, where you borrow an amount of DAI and you just repay some of it because you want in the end to have some DAI debt. So here again, the three modes. The mode 0 is the classic one where you need to repay the token, otherwise the transaction will revert. And 1 and 2, whether you want to have stable debt or variable debt in case you didn't repay in the same transaction. I think that's it for the flash loans V2 of Aave. Now let's talk about also the governance. We've done a good amount of work on this, and I think that we have a really nice model of governance. So the goal is that we at Aave Genesis team, we don't own the protocol. We can't do anything without the vote of everyone. So really, the owners of Aave protocol are the Aave token holders, and anyone that have Aave tokens can vote, can create proposals to change the protocol. And so I think that's really interesting, and yeah, that's a really good part of what we are doing, is seeing the proposals came from anywhere and be discussed in the public and then voted by stakeholders. So the V2 features multiple tokens for governance. So that means that our framework, and you could build on top of it, I think that we've seen Kyber that recently used our governance framework to allow multiple different tokens to vote on proposals. So that's one of the features. You can think also about, let's say you have two tokens, you have vested tokens and tokens. You can have those two tokens to govern. In the case of Aave, we have the Aave token and the staked Aave token that are governance token. And soon we'll maybe have another one. And for that, you have to look at the current proposals. Now, another feature is the separation between proposition and voting power, meaning that you have Aave token. You can, from having these tokens, you have two powers. You have the proposition power, so creating a new proposal, and the voting power. And since on V2 you can delegate this power, one or both, it's really interesting. So let's say you want to delegate the proposition capability of your tokens to an entity, you can do that without giving them the voting. So if you want to, let them propose, but then in the end you want to vote yourself or delegate to someone else, you can. It's really interesting. So this is an overview of how it works. Again, we have the Aave and the staked Aave tokens that vote on proposals. And here on the very top, we have the governance contracts, and people create proposals and vote proposals on these contracts. And yeah, on the right, we have the governance strategy contract. And it is in this contract that we say, okay, for our governance, the strategy is that we have Aave and staked Aave as tokens. But you could update this governance strategy to add another token or another one, change the ratios. That's how it works. And in the case of Aave, we have two executors of proposals, so two processes of proposals. One process that is short. So you make proposal that vote for 3 days, and that can be executed after 1 day of delay. This is for the upgrades of the protocols that are not critical. And we have a long time lock. So this time it's a long process where the voting is higher, 7 days, and you have some higher time lock. This is when we change things about the governance itself. That is really important. So to give you a concrete idea of how it works, we have a forum where where people that want to propose new stuff should submit some ARC, request for comments, Aave request for comments, and so on the forum we discuss about this, and then we create an AIP. On the AIP should correspond to a proposal. The proposal is the on-chain implementation of this proposal. And so then we create the proposal. For that, we need that the creator has enough proposition power, whether it's its own power or the one that he got from delegation. And then the proposal is voted on, and there's two conditions. There needs to be enough yes votes to reach a quorum, and the yes votes needs to be higher than the no votes, higher. And then the proposal is queued and executed. So here, for instance, we've done a lot of AIP already in the first quarter of 2021. We recently added balancer, for instance, on Aave. You can deposit them and borrow them. And here we are the AIP9 is the first step of adding a new stake token in the safety module. I'll talk about this later, but yeah, the Aave balancer pool tokens will soon be available for staking. So again, for the code, it's really simple. You can here you can use the function of the Aave tokens and the staked Aave token. There is a function delegate that will delegate both your power, the proposition and the voting power. There is another function that is called delegate by type, and with this function you can delegate only your proposition power or your voting power. Then the Aave governance contract. This is where you create proposals and you submit votes. Note that we also support off-chain voting, meaning that you can let voters vote off-chain, just sign a message, and then we can put them on-chain, and it doesn't need to be them. Yeah, now the staking. This is also something that is really interesting. We think that security is sexy, as Mark Zeller would say, and so people can stake tokens on Aave. For now, it's Aave. The token that you can send is Aave, and you get staked Aave. And soon you'll have the balancer pool tokens. And this allows us so basically the stakers put value into securing the protocol even more, and they earn some rewards. And the goal of that is that in case, even though we had 5 audits and we think that it's really secure, in case of there is an issue, the protocol it has capabilities to repay some debts that could appear or some malfunctionments. So yeah, this is also part of the governance. And yeah, basically you stake and then you get rewards, and you'll have to wait 10 days if you want to unstake them. And I guess that, so here you can, here it's if you want to stake your Aave tokens, you need to call the function stake of the staked Aave token. And first, of course, you need to approve your Aave. And by calling the function stake, the stake token will take some of your Aave and stake them in the contract. I think that's it. My time must be up, but yeah, we've got so many projects building on our Flash round, and our protocol is so exciting, and we can't wait to see you use our capabilities.
Cool. Hadrien, thank you. Thank you so much for the presentation.